Hello, second grade. I hope you all had a wonderful weekend and you're ready to get started with a new week of learning. This week, we're going to study robots and multiplication. I'm so excited to get started. Okay, second grade. So the first thing we're going to do is we're going to read a story about robots. Now, while we're reading the story, I want you to be thinking, what does the author want me to learn from this book and on each page? I want you to think about what's important on each page as we read. Second grade, this story is a little bit long, so I want to encourage you to kind of get cozy and settle in. Okay, robots. What's a robot? What do you think of when you hear the word robot? A blinking, walking, robo-talking metal person? Some robots really do look like people, but most don't. Robots come in almost every shape, size, and color you can think of. They can look like a fish or flies, lobsters or spiders. Some look like nothing else you've ever seen. A robot copies human motion while playing ping pong. A scientist gives Sojourner, a robotic rover, one last check before its mission to Mars. A robot, or bot, is a machine that has movable parts and can make decisions. People design it to do a job by itself. How is a robot like a person? It collects information from its surroundings. Then, it processes the information and figures out the best way to do its job. But a robot doesn't think the way a person does. It can only do things that the engineers and roboticists program into its computer brain. A robot in Japan steers traffic from highway construction. Tech Talk. Program, to give a set of instructions to a machine. Roboticist, a person who builds robots. Surroundings, the conditions and things around a person or object. Researchers built the first robots about 50 years ago, but people had been thinking about mechanical humans for a long, long time. 850 BC, ancient Greek poet Homer described bot-like creatures that did anything their masters asked. 1495. Italian artist and scientist Leonardo da Vinci drew plans for a mechanical man in his notebooks. 1961. The world's first robot went to work assembling cars at General Motors plant in Ewing, New Jersey. 1907. Roboticists in Stanford, California, USA built the first robot that could move and sense its surroundings. 1977. The Voyager 1 and 2 space probes were launched to study Saturn, Jupiter, and their many moons. 1996. Researchers at Honda introduced P2, the first human-like robot. 1999. Sony developed AIBO, a robotic dog that could interact with people. 2011. R2 was launched to the International Space Station, making it the first human robot in space. Every robot is designed for a specific job, and that job determines what the robot looks like. But no matter what a robot does, it has three kinds of parts: a computer, sensors, and actuators. A robot's computer is like a person's brain. It uses the instructions programmed by a roboticist to make the decisions. The sensors are like a person's eyes, ears, nose, and skin. They collect information about the robot's surroundings and send messages to the computer. A robot's actuators receive messages from the computer. They control the robot's movements, lights, speaking, and more. Sensor. A robot part that detects light, temperature, pressure, sound, or motion. Actuator. A robot part that performs the action. Here we have a photograph with labels. There's a video camera here for this robot to see, and a microphone here to hear. The Carnegie Science Center's RoboThespian on display. Sensors to feel, heat, cold, and pressure. Weird but true. Some robotic sensors detect things people can't, like magnetic fields. 7 cool robots. Robots can do lots of interesting things, which is which of these awesome robots would you like to have? Number 1. Each year, NAO bots compete in an international robot soccer match. Researchers make improvements after watching robots play. Inca is a life-size robot head that could greet people at a store or doctor's office. Number 3. RoboLobster may one day search the ocean floor for mines and sunken ship. Number 4. Reba was designed to lift patients from a bed to the floor. Number 5. Lean and Light HRP4 can stand on one leg. It also responds to voice commands. Number 6. In China, robotic waiters zip around restaurants delivering meals. Number 7. RoboTuna swims to explore the deep ocean areas and coral reefs. GoBots. All robots have movable parts, but only some can travel from place to place. That's because it's difficult and expensive to build bots that can go, go, go. Robots that weld car parts and inspect food containers don't need to move across factory floors. But when a bot has to get around, roboticists choose one of 3 systems: tracks, wheels, or legs. Tracks. Robots with tracks are rugged and reliable. They are perfect for moving across uneven ground, but they move slowly. Engineers designed them to disarm bombs, fight fires, and travel in space. This robot disarms bombs for the U.S. Marine Corps. It moves around on tracks to do its job. Wheels. A robot at a sewage treatment plant in France uses 4 wheels and solar energy. Wheels. Robots with wheels are fast, but they may tip over on bumpy ground. Roboticists build them to mow lawns, guard prisons, patrol buildings at night, and carry materials inside factories and hospitals. Legs. Robots with legs can step over objects or climb up walls. They are perfect for cleaning up chemical spills or exploring uneven areas of the ocean floor. This 4-legged robot was designed to explore the site of a nuclear accident in Japan. It can release a smaller robot that fits into small places. Nature knows best. Roboticists also study animals for ideas about motion. Borrowing ideas from nature is a science called biomimetics. Biomimetics. 2nd grade, I want you to look here and see this helped Miss Pryor pronounce this word, biomimetics. These little ladybug robots move just like the insects they are named after. Tech Talk. Biomimetics, copying the shape and movement of animals in a machine's design. This robot moves and climbs just like a gecko lizard. That makes it perfect for searching for injured people after tornadoes or earthquakes. Animals are really good at moving around on this planet. They hop across rocky cliffs. They slither and scuttle over sand. They fly and swim and tunnel underground. Many motion that animals use can also be used by robots. The LS3 robot has legs that work like a dog's. It can follow a person and move safely around trees and rocks. Engineers hope that one day the robot will follow spoken commands like a loyal dog. A robot named Cairo moves through the water just like a jellyfish. The U.S. Navy plans to use the beach umbrella-sized bot to keep watch over coastal waters. Cairo could also make maps of the ocean floor and study sea life. LS3 is being designed for the U.S. Army to carry heavy packs for soldiers. A thick layer of squishy material called silicone gives Cairo a body that looks like a real jellyfish. Imagine a robotic snake coming to life by remote control. As the robot wriggles from side to side like a python, its mechanical body inches forward. Tiny cameras line the bot's long body so you can see what the robot snake sees. This snake could help with rescues in natural disasters. Snakes are the perfect shape to navigate through collapsed buildings after an earthquake. They can go where people can't. Tech Talk. Navigate. To locate a place and plan a path to get there. Robot snakes called snake bots can climb trees and swim too. Weird but true. Doctors use tiny snake bots during some surgeries because they can curve around body organs. Robots at work. Most robots do jobs that people can't do or don't want to do. Name a repetitive or dangerous job. Somewhere a robot is probably doing it. Robots control some city trains at night, so human workers can get a good night's sleep. Factory robots arrange chocolates in boxes, spray paint cars, build computers, and perform many other jobs. Car companies depend on robotic arms to do dozens of jobs. These factory robots are welding together metal parts. Robots have no trouble working in blistering heat, freezing cold, or places that smell bad. They can explore active volcanoes, visit distant planets, and spend days tracking enemy soldiers in the desert. This computer art shows the ACTUV robot ship that is designed to track enemy submarines for up to 90 days at sea. Robots are useful workers because they don't take vacations or stop to eat lunch. All they need to do their job is power from an electric outlet or a battery. This photo of the 8-legged robot Dante II was taken just before it went into an active volcano in Alaska. Robots at home. You don't need to push or turn this lawnmower. It senses when it has reached the edge of your lawn and turns itself. Nobody likes mowing the lawn, so roboticists invented a bot to do the job. It senses an invisible fence so it doesn't leave the yard. Weird but true. In Tokyo, you can buy a piano-playing robot for $42,000. Nobody likes to do housework either, so now there are robots that can vacuum your rugs. When a vacuum bot senses a wall, it backs up and rolls in a new direction. There is also a robot alarm clock on wheels. If you don't get up, the bot jumps off your nightstand and rolls around your room. You have to get up to turn it off. Imagine having a robot that cleans your room. The LE Fetch Bot can do just that. Point a laser at any object you want, and the robot races across the room, picks it up, and delivers it to you. Roboticists hope that one day the LE Fetch Bot will answer to the voice commands. For now, people use laser pointers to give it directions. Researchers designed the LE Fetch Bot to help people who have trouble getting around, but one day it could be in homes all over the world. Roboticists are hard at work on the Urina. It's designed to help people who are sick or disabled take a bath or move from a chair to a bed. Urina can be controlled by a touch screen, a joystick, or voice commands. Pushing the limits. What did roboticist Kogoro Katora have in mind when he set out to build the world's biggest bot? He just wanted to see if he could. Kurata is like a lot of roboticists. They try new things just to see if they're possible. Other roboticists are working on bots so small they could swim through a person's blood. One day, these nanobots might be able to attack cancer cells or carry medicine to just one part of the body. Computer artwork of a medical nanobot in the bloodstream. Tech Talk, nanobot, a robot so small you need a microscope to see it. Katara's robot is the biggest robot ever made. You have to climb high to sit in the control seat of this 13-foot tall robot. Almost human. Researchers at Honda have been building robots that look and act like humans for more than 15 years. The latest version is called ASIMO. It can dance, balance on one leg, and even climb stairs. It can pick up objects, speak to people, and recognize faces and voices. Wow! Weird but true. There's an ASIMO action figure sold in Japan. Androids are lifelike robots. Everything about them is artificial. Sometimes it's hard to tell that they aren't real. Some androids seem to blink, breathe, twitch, and talk just like a real person. School children in Tokyo, Japan answer questions for their android teacher, Saya. Tech Talk. Android. A person that looks like a robot. Artificial. Made by humans. A roboticist named Cynthia Brazil taught her robot Kismet about feelings. When she started, Kismet was like a baby. She programmed it to like brightly colored toys and people and want to rest at times. She gave it 16 computers and many cameras, sensors for sight. Roboticist Cynthia Brazil works with Kismet. It reacts to what she does. Then she invited kids and grown-ups to come play with Kismet. When Kismet's camera saw happy, smiling faces, Kismet learned to react in a very human way by smiling back. Kismet can make different faces to show emotions, so she can be angry, disgusted, sleepy, or happy. Real robots or movie magic. Real robots can't move or speak as well as the robot characters you see in movies like Star Wars or WALL-E. What you see on the screen is a result of movie magic. Can you name these movie robots? Answers on page 37. Robots in space. Robots can explore places that humans can't go. Humans have traveled to the moon, but robots have landed on Mars, and they've collected information while circling Venus and Jupiter. Robots also have traveled to the edge of our solar system and even beyond it. In 1977, scientists launched 2 Voyager spacecraft into space. These spacecraft have traveled more than 11 billion miles and are still sending information back to Earth. Here's an illustration of Voyager, a spacecraft built by NASA engineers to photograph and study Jupiter, Saturn, and their moons. R2 has been aboard the International Space Station since 2011. The human-like astronaut uses camera sensors in its head to see R2's computer in its belly. One day, robots may work side by side with human astronauts. Tech Talk, Robonaut, a robot astronaut. 2 rover bots are exploring Mars. Opportunity has been cruising around the red planet since 2004. Curiosity landed in 2012. Both bots are studying the planet's air, soil, and rocks. Scientists are looking for signs of ancient life on Mars. They also want to know how much of the planet was once covered with water. Computer art of opportunity and computer art of curiosity. Scientists designed Curiosity for a 2-year mission, but they hope it will continue to send back information for even longer. Armed and ready. Curiosity's 7-foot-long robotic arm is loaded with tools. Its wire brush clears away Martian dust. Its hammer drill pulls rock samples from below the surface. You can build bots. Think you'd like to build a bot? You aren't alone. Each year, more than 200,000 kids ages 9 to 16 join First LEGO League. They work on teams that research and solve science questions or problems. Then they build a program Lego robot to do a series of jobs. After about 10 weeks of planning, building, and programming, many FLL teams get together at big events where they can win awards and prizes. Sounds like fun. Let your parent and teachers know. They can help you start on an FLL team at your school. 2nd grade, we have a robot team at our school for 4th and 5th graders. So maybe if you study robots super hard, you can be in that club when you're a 4th or 5th grader. Robots of the future. It will be a long time before a household bot does all your cooking and cleaning. But in just a few years, a robot might drive you to school. Right now, several companies are developing robotic cars that drive themselves. Covered with sensors, robocars are safer and use less gas than the cars we drive today. What other amazing robo-inventions will soon be a part of our lives? We'll just have to wait and see. This robotic car is taking pictures and mapping streets in Brasilia, Brazil. Okay, and here is a glossary. All right, second grade, awesome. Before we move on to math, I want to draw your attention to a strategy of reading nonfiction books. So I want you to notice when I was reading these pages, I usually read the main text first, and then I went on to the illustrations and their labels. But I want you to know there's not only one right way to do that. If you start with the labels, that's okay too. When you're reading, you just want to make sure that you're reading for comprehension and you read everything on the page. I would recommend always starting with the header so you know what you're going to read about. So I know when I read robots in space, I know that this is all going to be about robots in space. So some of this will make a little bit more sense to me when I read it. So I can either start with the main text and read the illustrations and labels, or I can start with the labels and then read the main text. You just have to come up with a plan for reading nonfiction that makes sense to you. Okay, awesome, second grade. Great job. So for Class Cake today, all you have to do is list 2 things that you learned about robots from our story. Awesome. Okay, second grade, I'm really excited because this week we're starting our unit on multiplication. Now that might sound a little bit scary, but I promise we're going to take it slow and you're going to get it and it's going to be super easy. Okay, so we are going to look at something called repeated addition today. So repeated addition is when you add something, the same number, more than once. So here we have 3 teeth, we have 3 more teeth, and 3 more teeth. So 3 plus 3 plus 3 equals 9. Awesome. Okay, so we are going to come down here and we are going to solve some problems together. Okay, so here we have 3 children in each picture and we have 4 pictures. So if we're using repeated addition, we are going to add 3 together 4 times. So 3 plus 3 plus 3 plus 3. Now, sometimes it's easy to lose track of that, so I'm going to go back and make sure that it matches. So there are 3 children in each picture, and there are 4 pictures. So 1, 2, 3, 4. Okay, so now I'm going to add these together. Second grade, but you can also use your addition strategies for these. So I know 3 plus 3 is 6, and 3 plus 3 is 6, and 6 plus 6 is 12. So second grade, that's so much easier than saying 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're using those addition strategies in our head to solve these problems a little bit quicker. Okay, we're going to go down and try again on another picture. Okay, second grade, so I want to know how many ice skates are all together. So there are 4 ice skates in each picture. So I have 4 ice skates in each picture and 4 pictures. So that's going to be 4 added together 4 times. So 4 plus 4 plus 4 plus 4 plus 4. Now remember, I want to keep track and make sure I'm doing this right. So 1, 2, 3, 4. Yes. So 4 plus 4, 4 times. Okay, so I can do the same thing I did on the other problem. So I know 4 plus 4 is 8. 4 plus 4 is 8. And 8 plus 8 is 16. Yeah, so I can write 16. And that is my answer. Great. Let's do one more together before I explain your work for today. Okay. Whoops. Okay, second grade, I want to know how many legs are all together in this picture. So we know that insects have 6 legs. So 1, 2, 3, 4, 5, 6. I have 6 legs 4 times. So 6 plus 6 plus 6 plus 6. Great. And we're going to solve it the same way that we solved the other ones. 6 plus 6 is 12. 6 plus 6 is 12. And I know that 12 plus 12 is 24. We're using those doubles that we learned a little bit earlier in the year and just making this really snappy. Okay, awesome, second grade. So I'm going to show you what you are going to be working on today. So today, you are going to have these pictures on ClassKick, okay? And all you need to do is for each picture, you need to write a repeated addition problem. Super simple. We're going to do one together. So we're going to do the watermelon one together. So the question is how many seeds? So I need to figure out how many seeds are in each watermelon. 1, 2, 3, 4, 5, 6. There are 6 seeds in each watermelon, and there are 6 watermelons total. So we're going to add together 6 times. 6 plus 6 plus 6 plus 6 plus 6 plus 6. Okay, now that's a lot. So I'm going to go back and count and make sure. 1, 2, 3, 4, 5, 6. Great. And I'm going to continue to solve it just that same way. So I'm going to circle all my pairs of 6 because I know that these are all 12. And 12. Awesome. Okay, I know 12 plus 12 is 24. And then I'm going to do 24 plus 12. I know 4 plus 2 is 6. And 2 plus 1 is 3. So my answer is 36. So second grade, all I need you to do, all your answer should look like is here. This is what you need to write. 6 plus 6 plus 6 plus 6 plus 6 plus 6 equals 36. I want to see the repeated addition and the answer. Okay? All right, second grade, make sure if you get frustrated or you need any help, you call me right away. I will help you. Do not worry. Okay, second grade, all right, have a great Monday. Goodbye.